Was the day we worked on powers of 10, which have really cool patterns to them. So we began by looking for some mental shortcuts for multiplying 5 times 10, 5 times 1,000, 5 times a tenth, 5 times 1/10,000th. And one person in the class said, you've got 5 groups of these, so just take out the 1 and put in a 5. And that works. And somebody else said that because we have 5 groups of 10, 5 times 10, we still have 5, but they're 10 times bigger, so that's 50. 5 groups of 1,000 is 5,000. 5 groups of a tenth is 5/10ths, and 5 groups of a 10,000th is 5/10,000. So we looked at mental shortcuts. And then we started thinking about how do you tell how many hundreds are in 430,000. And I showed you this little trick. So we know that this is the place value for the hundreds, and so what do I see up to that hundreds place value but 430? Check it. 430 times 100 has to equal 43,000, and it does. India has over 1 billion people, so here's the number 1 billion, and I said how many thousands are in that? And again, this is the thousands place. So look at everything to the left, and I see 1 million thousands in a billion. You can just see it right here. Then check it. 1,000 times 1 million is a billion. There are 1,000 millions in a billion. We're talking big, powerful numbers. All right, then we checked your homework. And then we looked at some new vocabulary words, and most of you knew in 5 cubed, or 5 to the 3rd power, this is exponential form. This is standard form, the regular way you write the number. The 5 in this case is called the base. The 3 is an exponent. And what this 3 means is use that base as a factor 3 times. So you multiply 5 times 5 times 5 to get the 125. If we have an exponent of a 4, we read it as 5 to the 4th power, or 5 to the power of 4, and that would mean we use 5 as a factor 4 times. And that would be 5 times 5 times 5 times 5, or 125 times 5, which is 625. Then we looked at why is it that numbers to the power of 1 equal the number itself? Well, if 5 squared means 5 as a factor twice, and 5 cubed means 5 as a factor 3 times, and 5 to the 4th power means 5 as a factor 4 times, then 5 to the 1st power is just 5 once, so it's just 5. 16 to the 1st power is just 16. 2 to the 1st power is 2, and 1 to the 1st power is 1. And then we explored patterns of powers of 2. You're just doubling. But beware, some of you said 2, 4, 6. We're doubling. We're not adding 2. We're double, 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 double. And you can see that numbers get really big really fast. Why these are called powers is if you look at repeated addition, 2 times 10 is just 20. But 2 to the 10th power is 1,024. So it is a lot bigger. The numbers get very big. And we looked at patterns between the number as a power of 10 and the standard form, specifically with the 0 pattern in powers of 10. So 10 to the 4th power is a 1 with 4 zeros. 10 cubed is a 1 with 3 zeros. 10 squared is a 1 with 2 zeros. 10 to the 1st power is a 1 with 1 zero, and 10 to the power of 0 is the 1 with 0 zeros. So that is just equal to 1. And then we just looked at the base 10 blocks, and I was showing you if I have 2 of these little cubes, and I call each of those one little cube, and I multiply by 10, I'm really just trading for two base 10 blocks that are each 10 times as big. So instead of 2, I have 20. And if I traded these by multiplying by 100, I would trade these 2 little cubes for these 200 flats, and I'd have 200. Or I can trade these 2 for 2 big cubes if I multiply them by 1,000. So you only move the decimal point because you have the same amount of pieces. They're just bigger, and that's how base 10 works with place value. Next, we looked at a decimal that wasn't a whole number, 5 3/10. And what's the pattern we multiply 5 3/10 by? 10 or 100 or 1,000 or 10,000. And what you guys found is that you really just are moving the decimal once to the right when you multiply it by 10. That gives us 53. twice to the right, we multiply it by 100, that gives us 530. And 3 times to the right, and because I move it once to get it behind the 3, I have to tag in 2 more zeros by moving that decimal a total of 3 times. And 5 3/10 times 10,000, we move it 1, 2, 3, 4 times, and we get 53,000. So the big pattern is whatever the exponent is, or how many zeros there are, that's how many times you move that decimal point to the right, because they're getting bigger, because we're multiplying by numbers bigger than 1. Okay, then in your groups, you put your heads together to figure out these answers. So 5.6 trillion. Well, it's 5 trillion. That 0.6 is 6/10 of a trillion, so that's 600 million. You can also think of this as just multiplying 5.6 times a billion, which moves the decimal 9 places to the right, because 1 billion has 9 zeros. 81 trillion. Well, a trillion is a 1 followed by 12 zeros, so you have to put in 12 placeholders. And 4.4 million is 4,400,000. Again, I moved the decimal 6 places to the right because a million is 10 to the 6th power, or a 1 followed by 6 zeros. Really, these are multiplication problems. You're just multiplying 4.4 times a million, 81 times a trillion, and 5.6 times a billion. In your scientific calculator, I showed you how to use the x squared key. Literally, if I want to do 8 times 8, it's such a common procedure to square a number that you have a special calculator button, and it's this squared key. So I just hit 8, x squared, and that gives me 64. But what if I want to raise 8 to the power of 3, or the power of 4, or the power of 5, or any other number? Well, you have this key on most scientific calculators, and this is the exponent key. It looks like a little tent. Some scientific calculators have a y to the x power, or an x to the y power, and somebody today even had an exponent key that looked like this. It was an x with a blank. All of these 4 keys do the same thing. If I want to find 8 to the 5th power, I put in 8, I hit any one of these 4 keys, then I put the 5, so this is the base, the exponent key, the exponent, enter or equals, and that gives me the answer very efficiently. All right, more heads together, heads apart, and you did these problems together. So you had to find out how many thousands are in 6 billion, which gave some of you a little bit of a struggle. Well, if you write out the number 6 billion, and again, go to the thousands place, everything to the left of that is your answer, and that's 6 million. Also think of 1,000 times what number will give me 6 billion? Well, that number is 6 million. In 4 to the 7th power, 4 is the base, 7 is the exponent. If I move the decimal 5 times to the right, I get 614,000. And if I divide by 10 to the 5th, I move the decimal the opposite of the right, but to the left 5 times. 1, 2, 3, 4, 5, and I must put in 4 placeholders. And then I asked you, how do you read that number? Well, the 4 is in the 10 millionths place, so you read it 614 10 millionths. There should be a dash there between the 10 and the millionths. And then we did some more heads together, heads apart, and you had to write this $7.1 million as a standard numeral. It's $7,100,000. And 81 trillion miles, that's the distance that Sirius is, which is the brightest star in the sky after our sun. The distance it is from Earth, it's about that far. And that's 81 followed by 12 zeros. And then the bonus question was, how would you write this 81 trillion as a multiplication problem to a power of 10? So if I say it's 8 1/10 times 10 to the what power, I just go to the end of my 81 million and I count back how many decimal places would I have to move it to put it between the 8 and the 1, and it's 13. So 8.1 times 10 to the 13th power is 81 trillion. And then you have a little homework to do. Remember, you can choose either the basic or the challenge. Use a pencil, fold your paper in half, and go down your columns. Your quiz next class is on lessons 1.3 and 1.4. I would look over the screencasts and look over the examples in your book. Look over your homework, see if you had any problems on anything, and you'll be set if you do that. That's it.